All right, well, we waded our way through solving systems of equations, two equations. A little bit later, we're going to solve systems of three equations. But now we're going to look at solving systems of inequalities by graphing. And so we have some instructions here. Well, step one is to graph each inequality, shading the correct area, and then identify the region that is shaded for all the inequalities, and that is the solution of the system. And so what we're looking for is intersecting regions when we graph it, or overlapping regions, or regions that coincide, different terms we could use. We're looking for these intersecting regions. Now, one thing we do know, if we remember, and we're going to look at, we're going to jump over here to the calculator in just a few moments, and we're going to graph these two systems of inequalities, and then we'll take a look at these two. And so you might want to jot these down if you got your textbook with you, which if you're in class listening to this, you should have your textbook with you. I'm looking at guided practice 1, or example 1, guided practice 1A and 1B. This is found on page 146. Now, if you happen to be viewing this somewhere without your textbook, I can only hope that people would actually view these in some other time other than the classroom. I don't know if that ever happens or not. I could go and check, see how many times it's been viewed. That may give me some clue, but whatever. All right, now, if you're having to do these by hand, we know that we use a test point. We're typically going to use 0, 0. And we know that we're going to shade an inequality. We learned this back in the last chapter. If 0, 0 gives us a true statement, we shade the region where the 0, 0 lies. If plugging in 0 for x and 0 for y gives us a false statement, then we shade the opposite side. And so when we're looking at systems of inequalities, we're going to do the same thing, but we're looking for a region that is shaded for both inequalities. And if that's the case, then that is the solution to our system of inequalities. So again, if you got your textbooks, we're going to be moving over here to the calculator. Oh, one thing I forgot. You know your calculator is not going to give you the solid and dashed lines. And so when you're on a test, or if you're in an exam, then you've got to know that this, like this one here, has got to be a solid line. And this one is going to be a dashed line. Now, one way to help you on a test, this is a tip, is do one first where you know that you're recognizing whether you got solid or dashed lines. And then when you graph the second inequality, that'll help you recognize what you're looking for. Because guess what they're going to do on a multiple choice type test? Well, you're going to see the possibility of the dashed and solid lines being incorrect. And so you got to be careful to recognize those. All right, we're going to move over here to the calculator, and we are going to solve these two systems of inequalities. All right, well, here we are. We're over on our calculator, and we're going to be graphing systems of inequalities. And my first inequality in guided practice 1A is y is less than or equal to negative 2x plus 5. So I think the first thing I want to do is go ahead and get this set up into a less than mode, which is the triangle on the bottom. Then I'm going to click, I'm going to put enter here. And I'm going to go in here now and graph the inequality. Okay, so we got negative 2x, being careful not to use the subtraction button, but the negative button, plus 5. And I'm going to go ahead and look at this right quick before I enter the second one. Okay, so there's my shaded region, obviously. That's the solution to that. And I've got to know and remember that this is supposed to be a solid line right here. Now, let's move back to the y equals, and we're going to put in the second inequality. So I'm going to go down here to y2. I'm going to go over here and change this one. Now this inequality is y is greater than or equal to negative 1/4 x minus 6. And so let's change this to a greater than symbol. And whoop, there it was. Triangle on the top. And we're going to say OK. And so our inequality is negative 1/4 x 1/4 x minus 6. And now let's hit the graph button. So there's my first equation. Here comes my second. All right, this area here, where we got both the red and the blue pixels, this general area right here is, in fact, the solution set to our inequalities. And remembering that this line right here is a dashed line. This one I saw first, it's a solid line. This one's going to be a dashed line, and there's my region that gives me the solution set to these two inequality symbols. All right, now let's jump over here and we're going to change this, and now we're going to graph the second. This is 1b. Whoop, didn't want to do that. That's fine. Okay, let's see. We got y is greater than or equal to the absolute value of x. Let's clear this. Let's go back over here, and we're going to have to change this one to a greater than symbol. I'm going to hit enter. I'm going to go down here. I'm going to move that back. That gives me a greater than symbol. I'm going to hit enter and OK. And let's see. So let's go ahead and enter this equation. And I got to get the absolute value in here. I'm going to hit math. I'm going to go to number. I'm going to choose option 1, which is going to give me an absolute value. And we're just going to simply put in x. Get beyond that absolute value. So I'm going to go ahead and delete this inequality for right now, because I want to look at the graph first. I'm looking for a V-shaped graph here. I see it. Okay, and there's my region that satisfies that. And let's move over here. And now we're going to enter the second inequality. Let's see. This is going to be a less than, so I've got to change that right there. And we're going to move it to a less than. And we're going to click OK. Now remember, the one that had my absolute value is going to be a solid line. This one's actually going to be a dashed line. My calculator is not going to give me that information. I just got to know it. So now I got 4/3 x plus 5. And I'm looking for the regions that coincide or overlap, or I should say intersect. Here comes my second one. And right in there, that little piece right there where this cursor's going back and forth is the solution set to my inequality. All right, cool. That's it. Intersection of the intersecting regions when we're solving systems of equation by graphing.